difficulty comes. Alright. So that's f of x. F dash x is equal to 4x cubed minus 12x squared. I know that at the stationary points, I know that the f dash of x is equal to 0. That implies that 4x cubed minus 12x squared is equal to 0. This is algebraic, so you factorize it. Take out what's common. 4x squared comes out. I'll have x minus 3 inside is equal to 0. So that means 4x squared is equal to 0, or x minus 3 is equal to 0, making x equal to 3. That means x squared is equal to 0, so x is equal to the square root of 0, which is 0. So there's a stationary point when x is 0 and when x is 3. The corresponding value to that, so there's a stationary point at 0, 0. And the corresponding point to that is equal to minus 27. So there's a stationary point at 3 minus 27. So they're my stationary points. But I don't know what's the nature of them. I know there's one at 0, 0, right? And I know there's one at 3 minus 27, where we say that's where it is. I can have whatever scale I want. So there's a stationary point at 0, 0, and there's a stationary point at 3 minus 27. What do I not know about them stationary points? Their nature. So I don't know the nature of those stationary points. What's the best way to check for their nature? To get the slope on either side. Why? It tells of every type of point. Yes, d2y dx squared would be easy to calculate here, but it won't tell me if I have saddle points. So dy dx at x equal to 0. At x equal to 0, dy dx is, no, I can't take 0, so I have to go either side of the 0. At x equal to minus 1, that implies that dy dx is equal to minus 1, 4 times, minus 1 to be cubed, minus 12 times minus 1 to be squared. Minus 4 plus 12, it is minus 4 minus 12, it's minus 16. So what's happening here? The graph is decreasing. At x equal to 1, that implies that dy dx is equal to 1 minus 4, which is minus 3. So what's happening here again? It's decreasing. So what type of a point have I got? A saddle decreasing. Is that all right? Now, for the other point, the point 3 minus 27. At x equal to, I need a point on the left of the 3. Will the 1 do? Yeah, do I have to do 2? No, 1 will do. So at x equal to 1, I know dy dx is minus 3. At x equal to 4, that means that dy dx is equal to 4. 4 times 4 to the cubed, minus 12 times 4 to the squared. 4 times 64, so 4 is 16, 256, minus 12 16, 12 times 16 is positive. Yes. So what type of point have I got here? Goes from negative to positive. I have a minimum turning point. So what will my graph look like? It decreases and it levels up. And it drops again and it turns into a, that's my point. What type of a point have I got here? A saddle point. A saddle decreasing. Here I have a minimum. Right? So that process is fine and easy. The only difficulty you can get into is how do you solve something here? Now the ones that cause difficulty here are the logs and the e to the x's, not the algebraic ones.